let us hypothesize that all mass defects in the universe are converted into an ultrafine form of matter called ether. Mass defects are a universal phenomenon, occurring in every active star, supernova, colliding neutron stars, and merging black holes, all of which create large-scale mass defects. Consequently, space becomes filled with ether. Due to gravity, each massive body maintains a dense region of ether around it. The density of the ether is highest near the body and decreases with distance. Owing to immense gravity, the galactic center is enveloped by an extremely dense region of ether. The S2 star, as the star closest in orbit to the galactic center, would therefore experience high etheric friction and a buoyant force from the ether as it orbits the galactic center. With all this in mind, please provide a possible explanation for the Schwarzschild precession of the S2 star. Please disregard the special and general theories of relativity. In the context of this hypothetical scenario, the Schwarzschild precession of the S2 star could be explained by the interactions of the star with the dense ether surrounding it, particularly near the galactic center. Here's how. Aetheric drag. As the S2 star moves through the dense ether, it might experience a type of friction or drag force. This would be similar to the way a satellite moving through Earth's atmosphere experiences atmospheric drag. This drag force could slow the star's motion slightly, causing it to follow a slightly different path than it would in a vacuum. This could potentially result in a precession of the star's orbit. Buoyant force. Similar to how an object submerged in a fluid experiences a buoyant force, the S2 star in this dense ether might also experience a buoyant force. This force would act perpendicular to the direction of gravity, and it might cause the star to be pushed slightly off its expected course, adding to the precession. Aetheric pressure gradients. If the density of the ether decreases with distance from the galactic center, there would be a pressure gradient in the ether. This gradient could result in a net force on the S2 star, pushing it in the direction of lower ether pressure. This force could add another component to the star's motion, contributing to the precession. Aetheric tidal forces. Similar to gravitational tidal forces, there might be aetheric tidal forces due to the varying density of the ether around the S2 star. These forces could also contribute to the precession of the star's orbit. However, it's important to note that this is purely hypothetical and would require a significant overhaul of our current understanding of physics. In the real universe, the Schwarzschild precession of the S2 star is explained by the general theory of relativity, which has been experimentally confirmed to a high degree of accuracy.